All right, now coming to the next part of geometry, that is a cyclic quad. What do you mean by cyclic quad? You know the quadrilateral, cyclic quadrilateral, okay? Quadrilateral means a shape with the four side, isn't it? A shape with the four side and four corner point. We call it a vertices. So that is a quadrilateral. And you know the examples of quadrilateral, that is parallelogram, rectangle, trapezium, rhombus, etc., etc. Then what happened? If you can fit that quadrilateral exactly inside the circle, then we say it is a cyclic quadrilateral. The example is here. You can see that A, B, C, D all are on the. So we can see that all the vertices of a quadrilateral on a circle, that is A, B, C, D, then we can say that cyclic quadrilateral. And the cyclic quadrilateral, in short, we say cyclic quad. Okay, and it has many properties. One or two you need to prove. The first one is opposite angles of a cyclic quadrilateral are supplementary. Supplementary means opposite angles 180 degree, that is angle A plus angle B, angle A plus angle C. Angle C is equal to 180 degree. Similarly, angle B plus angle D also equal to 180 degree. Two angles sum is 180 degree means it is supplementary. This is one of the properties. Okay, then another property here, exterior angle of a cyclic quadrilateral is equal to interior opposite angle. In short, exterior angle of a cyclic quad we say. So look at that diagram D. You can see that exterior angle D1, D2. There D1 is equal to angle B. So these two properties you need to know, and sometimes, especially the first one, they will ask you to prove. Okay, that is opposite angles of a cyclic quadrilateral are supplementary. How do you prove that? You have to construct the center is O and construct BO and DO. Okay, then the theorem is angle at the center, that is O1, O2. O1 is 2 times A, isn't it? Okay, that theorem, we are just using the idea of the angle at the center 2 times angle at the circle. So proof, how do we write it? I will show you here. Proof is O1 is equal to 2 times A. Do you agree that? Okay, because of the previous theorem. Here the reason is angle at center is equal to 2 times angle at circle. Is it clear? Similarly, O2, that is this one, O2 is equal to 2 times C. Is it clear? Very same reason, angle at center is equal to 2 times angle at circle. So very simple to prove that. Okay, now what we need to do, just to add these equations, equation 1 and 2, that is O1 plus O2 is equal to 2 times angle A plus 2 times angle C. Do you agree that? Okay, we are adding the equations. How do you add the equation? Left hand side add it and right hand side also add it. That is this equation number 1 and equation number 2. So 1 plus 2 will give you like this. So what is O1 plus O2? That is going to be a full circle. Oh, that is 360 degree. Is it clear? Here 2 is common, take it out. Angle A plus angle C. Then divide both sides by 2. That is going to be 360 divided by 2 is equal to, it is very easy to understand, angle A plus. So it's going to be what? Angle A plus angle C is equal to 180 degree. Similarly, from A and C, if you join to O, we can prove that angle B plus angle D is equal to 180 degree using the same idea. So we can just write it here. Similarly, we can prove angle B plus angle D also equal to 180 degree. So this is how we prove that. So cyclic quad means opposite angles are supplementary, isn't it? All right. So we can see that. Just think about a rectangle. What are the angles on a rectangle? 90 degree, isn't it? So 90 opposite angles are 90 degree. 90 plus 90 is 180, which means a rectangle is a cyclic quad. You can draw the rectangle inside a circle. Similarly, square also, because all the interior angles are 90 degrees. Is it clear? So the property. So at the same time, square or rectangle at the same time, it's a quadrilateral and a cyclic quadrilateral also. Is it clear? All right. Now we can move to the next theorem. Exterior angle of a cyclic quad is equal to interior opposite angle. Okay. Okay, so what is the exterior angle? So let me, when you extend one side of a polygon, see this CD I extended, this CD I extended and I got an exterior angle D1, and you have to prove that D1 is equal to B, isn't it? How do you prove? Here, very simply we can prove this one, because what is that? D1 plus D2 is equal to 180 degree. Do you agree that? Yes. What is the reason? Angles on a straight line. Agree. Sum of the angles on a straight line is always 180 degree. Then what about D2 and B? D2 and B also 180 degree, because it's a cyclic quad, isn't it? That is D2 plus B is equal to 180 degree. That is opposite angles of cyclic quad. Opposite angles of cyclic quad is the reason, isn't it? Since both of them are 180 degree, which means this side is equal to this side, that is D1 plus D2 is equal to D2 plus B. Do you agree that? Because you can see that both equations are giving what? The same answer, 180 degree. So let me equate left hand side. D1 plus D2 is same as D2 plus B. The reason is both of them give what? 180 degree. Now we can simplify. So that is, we can see that D2 in both cases, isn't it? Okay, so let me send D2 the other side. That is D1 is equal to D2 plus B, and this D1, D2 will go other side minus D2, which is equal to what? D1 is equal to D2 minus D2 cancel is going to be B. So we are done. That is D1, the exterior angle, is equal to opposite interior angle. Is it clear? So this is how we prove that one. So here this theorem is very important. Opposite angles of a cyclic quadrilateral are supplementary. Is it clear now? Now we are left with only one important theorem, that is a tan-cot theorem. In my next video you will see tan-cot theorem.